Hi guys, welcome back. In today's lab, what I'm going to look at is running through task 1. I'll go through my solution and then just show you any points of interest along the way just quickly. Once we've got task 1 set up and running, I'm going to take a little bit of time to go over pointers, and then finally I'll do a small implementation of task 2, and that should leave you guys well on your way to work through tasks 3 to 6 yourself. So the first thing we're asked to do is create a class called point, and it's going to have x and y coordinates stored as doubles. So that's pretty simple. All we need is a .h and a .cpp file for point. We want to make sure we've still got our macro guards as usual. So we've got our if not defined, then define it, and then we've got our end if down here. I'm giving it a namespace for Lab3, that's fairly normal. And then I've got my private variables down here, it's $x and $y. You'll notice with this, I've got all of my commenting above it. This is where I simply list my preconditions and postconditions. This is the way it's presented in the textbook, and that's my preferred style. You can use either the way it's presented in the textbook or the way it's presented in lectures. It doesn't matter which one, like which mode you use, just as long as it's consistent. For this next part, they're simply asking us to either create points at the origin or with values provided. That's pretty simple. What that is over in point.cpp, you can provide initial values for x and y, and then just make sure that the point's x and y coordinates are set to equal those. Alternatively, you can use the default option where if values are not provided, they are going to be set to 0. So for this next part, all we need to do is to create some accessor and some mutator methods for our private variables. This is nothing we haven't done before. They're just going to sit in our public section, or fairly normal. We've got our set x, set y, set point, and then we've got get x and get y. I won't explain those too much. The only real difference is with these get x and get y, I've listed them as constant functions, and I've done that using the keyword const. What that lets me know is that no changes are going to occur during the execution of this function. That's when you're meant to use const. It's just to show when something needs to remain constant during the execution or its lifetime over a certain function. So for this next part, all we need to do is overload our cout operator. This is very similar to what you've done in Seng 1110 for those of you who have completed Seng 1110. It'll be very similar to overloading the toString on objects, which is what we did whenever we wanted to print out details of a specific object. In order to incorporate it, we list it as a friend function. A friend function that you'll see here, this is my friend function, it sits inside the namespace, but then it sits outside of the class. So this is my class here. Inside the class here are all our member variables, and any friends are going to live down here. The reason why we put our friends down here, or the reason why we need friend functions, is because in this case we're passing in a point object. So we need a fully defined point before we can pass it in and print the details of that object. You'll notice I'm still listing the point as constant because I'm not going to be changing it during the execution of this function. Okay, so just one of the other things about this overloaded cout operator is that I'm trying to work with the outstream. In order to work with an outstream, I need to include the IO stream package up here. That's my input-output stream package. And then also I need to make sure I'm accessing it from the std namespace. Now I can access it in two ways. I can do it like this, how I've got it here, and just state std : before the object which I want to use. The other thing I can do is I can just simply up the top type in using namespace std, and that would also give me access to that namespace. It doesn't matter which method I use, just as long as I'm getting the access I need to happily compile this overloaded function, or operator, sorry. Just going to set it back to the way it was. And then with our implementation of it, if we just go over to point.cpp, you can see here, this is my outstream and this is what I'm going to be returning. I'm actually also using it as an input parameter. It's called outs. So essentially I'm returning the outstream which I've passed in once I've finished building it. It's all fairly standard string builder stuff. The syntax is a little different. You will get used to that, but essentially we're just building a string in the format that they've stated, and then we're returning it back as an output string. So finally, all I need to do is demonstrate the behavior of the new class. To do that, I've just gone in and created a main, like a main.cpp. It's got my main function here. All I'm doing is creating a point and then I'm modifying it and then I'm printing out the details for it. When I'm printing the point details, I am using that overloaded cout function. We'll take a look and see how it runs. So I've now compiled that program and I'm ready to run it. So you can see here, if I just run my program, essentially I'm creating a point at the origin, so we'll print out the point. Okay, and you can see here the point's values are at the origin, that's 0.0. So now we'll continue with the program and we'll put in 5 and 6 as our values. And now you can see it's been updated and it's printing out 5 and 6. So I'm going to take a moment right now to talk about pointers just a little bit more. So last week we looked at creating objects on the heap using the new keyword and using a pointer to point towards that object. This week what we're going to look at is the 3 main components of that pointer. Firstly, the pointer itself lives on the stack, so it's going to have a stack address. Now, if you wanted to access that address to print it out, you can do so by using the ampersand character. Remember, the ampersand will get you a memory location. Then here, for the heap address of the pointer, if you wanted to print that out, all you would have to do is print the pointer itself. That will give you access to that heap address. Finally, if you want to access the object which that pointer is pointing towards, first you need to dereference the address. So to dereference, all you do is you use this little star and then you put that next to the heap address or the pointer name, and that will then access the object which is stored at that address. So just to show you what I've done, I've got some little couts here for my pointer. So the first one is using the ampersand. You can see that is my stack address. The second one is the pointer itself, and you can see that has got my object address, or sorry, my heap address. And then finally, my dereferenced pointer object is going to bring in that overloaded cout function where I'm going to print the actual object. So you might remember from last week where we brought in the binary operator to access the object at a pointer location. Essentially, that is the same thing here where I've dereferenced a pointer by using the star point A. So that way I'm getting access to the object here, and now I can use the dot operator to access that function. Essentially, these do exactly the same thing. It's just 2 different notations for doing it. Okay, so the last thing I've done today is I've implemented this getLength function or distance function. It's just going to find the distance between 2 points. So what I've done is I went to my .h file, and the first thing I did was I defined the function. I've ensured that it's taking in a point A, and I've ensured that it's taking in a point B. In both cases, I've listed the point as constant because we're not going to be making any changes to the point during the execution of this function. Finally, I've made sure that it's returning a double, so that way we're actually getting the length. Then when I've gone to implement it, it's just a simple Pythagoras. All I needed to do was get a length for A and a length for B, and that was based on my X values and then my Y values for each of the points. And then all I needed to do was take the square root of A squared plus B squared. So there was nothing difficult about finding that distance. Finally, in main, I've adjusted that. So now I'm creating a point A, and I'm still creating that at the origin, just for the purpose of showing this example. Then I'm creating a point B, and I'm creating that at the coordinates 4 and 5, so x is 4 and y is 5. And then finally, I'm doing a printout. Now, when I'm calling the function, I don't need an object to call that function with. All I need is the function call. So you're probably used to having like object name and then dot and then a function call. I don't need to do that because this function is not inside the actual object definition. All I need to do is say get length, and then I pass in the objects that I want to send it. Those are the dereferenced points, and then that should print out the value for me. So just to check that everything is working, I've compiled that and I'm ready to run it. So if I just run that, I create my point A, and we can see it's at the origin. Then I create my point B, which is at 4 and 5. And then finally, I print out the distance between them, and it's 6.40. And I know that that's correct because that is what the distance between those 2 points is. So that's the end of today's demonstration. That's certainly a lot for you to get on with, and then there's a few other functions here which you're going to need to define. There's another friend function, there's some overloaded operators still, but you should be able to continue on with this, and good luck with it all.